But I have to specify the email.
Wait, I think you meant 3.
You should try your.
Oh, you did 2 and then you did 1.
Okay. Hello, everyone.
How many of you are here for Godot?
Or just your username. Wait, what
Cool.
are we doing Godot today?
Yeah,
Yes.
Godot.
No, it's user.
If you want to join, come to the
What,
front.
what are we doing?
Physics.
Probably.
Yeah.
Join us.
Okay.
So-
Wait, no. Wait, maybe. I'll take it.
So, hello, everyone. Welcome to the second Godot workshop. Today we're talking about physics. So, what we're going to be doing is over the next few workshops, we're going to be making a simple platformer, and we're going to be using physics with colliders and rigid bodies. Next time we'll be adding some tile sets, and we're going to talk about how to make a character controller and how to organize your code and do input with it. So what we're going to do is we're going to go through each step of the process and show you how to do it, and then you guys are going to try to do it on your own, and you can just ask us if you have any questions about anything. And I think we have posted the slides on Discord, so you can reference those if you want. Okay, so we're going to start by making a new project. So I'm just going to call this the workshop project.
I think that's but we're not gonna,
Oh God, I am not used to this layout.
because there's so many things I missed out on. I think I was done better if I just
Probably
clicked
make
on
it default so that
I'm gonna-
everyone else knows what they're looking at.
Yeah, I'm going to do this.
Send.
So what I'm going to do is we're going to make
I call them
4
right?
folders. We're going to make one called scenes, one called assets.
Excuse me, sorry.
Did we?
For the stream?
Yes.
Okay, cool.
Did they know me? Did they get set up and all that?
Yeah, we're just
Yeah,
making
we're just
folders.
setting up.
Okay.
Prefabs. And you don't have to use this setup, but this is just what we're going to be using.
I would highly recommend having some organizational system somewhere.
Yes, please don't just put all your scripts all over the place, because it'll drive you insane.
It'll drive your team members more insane.
But insanity is good.
That's not true.
Especially when you're a week away from presenting.
Yeah.
What?
Insanity.
Between assets, prefed, scenes, and scripts.
Yep.
Yep. You can categorize it however you want, just have some organizational system that makes sense.
Right, how do I create a new folder?
You should be able to right click.
Yeah.
Yeah.
All right, are most people ready to move on? I'll take that as a yes, I guess. Okay, so what we're going to be doing is importing some pre-made assets that we're getting off a website. But we need to change some of our import settings because just like Unity, Godot by default will apply an aliasing filter to textures, and we do not want that because it's going to make our art look blurry. So what we can do is just to have something that is an image, we can click on our icon that comes with our project. And if we click on import at the top here, we can change this to, we can hit preset and click 2D pixel and then re-import. And
Set as default.
See it set as default for texture, and what that's going to do is automatically import every pixel image that we import with those settings. So if we drag this in, you can see does not have a filter on it. It's nice and sharp.
You'll want to make sure that you applied the filter correctly, because sometimes you might like click off of the image and it won't apply or whatever.
Oh, it's so clean.
This keycap just fell off.
Huh.
There we
Big
go.
keyboards these days.
Okay, so for this series, we're going to be using a royalty-free platformer asset pack, and you don't have to use it if you want, but we're going to be using it. So
It's nice to have just some placeholder assets that you can replace later. It allows you to, get started quicker and just have something to work with. I typically just use the Godot icon and stretch it to be whatever size I need it to be.
and it,
I feel bad because I'm downloading it for free. But
Yeah, it's
Oh,
it's
I-
education. We're not making
I
money
left
off
the
of it.
slides. Whoops.
says you.
Well, cannot speak for you.
I should have done that on the other desktop. Let me. There it is. So I just unzipped it, and I'm going to drag all of these into our assets folder.
Welcome.
This is not what we want. I don't know how that opened. Can I not drag this in?
You probably have to open it in Explorer.
Oh yeah. So, damn it. So you can either drag stuff directly in here, or you can just open your projects folder in Windows Explorer or whatever and drag in your folders that way. And when you click back in, it should update.
Yep.
And let's just make sure our import settings are working. Yep. All right.
If they're still blurry, it's probably easier to just delete all the assets and then change the default and re-import them.
Yeah.
So like, why is it automatically kind of blurry?
Because I think it's actually more performant to have a filter applied than to not. And for most textures in 3D, it looks worse to have no filter over it than it is to have a filter over it. So yeah, most games don't actually use pixel art this way.
Okay, so next thing we're gonna do is just create a new scene. And I'm just gonna call it main and put it in the scenes folder. And we can click run. It'll have us select a default scene. And there we go. Has everyone gotten this far? Does anyone have any questions?
Where's the assets folder?
You have to create it.
Oh.
That's the whole make an organizational system.
Yeah, these
It's
are
just-
the 4 folders
Yeah.
that we used.
Oh.
You just create these folders, and then when you have your assets downloaded, you drag your assets into that asset folder.
Okay.
Anyone else have any other questions?
Alright, we ready to move on? Okay, so we're going to set up our player script with some input so we can move the player using a script. And right now we're not going to worry about physics, we just want to get some basic movement in. So we're going to start by adding our sprite, or adding a sprite. We'll call it player.
You can either use that plus icon in the very top left, or you can just right-click the root node and click Add Child Node to add a node. And you want to search for Sprite. Make sure it's not a Sprite 3D.
And then you can either, to add a sprite to the player, you can either click this texture button and click load and browse to it, or you can just drag it right over.
Make sure you have the player selected in the scene view or in the scene tab so that you can click on the properties in the inspector.
Yes. Now if we run our scene, we will have a very tiny player like that.
A small player in a big scene.
And just make sure, again, that your sprite is not blurry and that you changed your import settings.
Yeah. So you can just zoom in on the sprite in the editor, and if it's blurry, change your import settings.
Okay, so now we're going to add some input to our player, and this works very similar to Unity if you've used it. There is an input manager that you can add input actions into, and you can assign different keys or buttons to those actions. So if we go up to project settings, input map, you can see it already provides us with a few actions already, and we're going to add a few new ones. We're going to say move up, move down.
It's a platform where we don't have move up or move down.
That's a good point. We're going to do move left and move right.
We also have to jump.
And jump. And you can name these whatever you want. Sometimes it's a good idea to give them a prefix that's consistent, but in this case it's fine. So, and then does it talk about... Yeah, so well, then what you can do is click this little plus icon next to the action and click any one of these, but we're going to do a key. So for move left, we're going to click A. For move right, we're going to do D, and jump, I think, was space. Yeah. Space. And you can add multiple keys to each action. So like if we wanted to put left and right on, if we wanted to put left and right on these as well, you can do that. We can do like W for that, I guess.
You can also have joystick axes and joystick buttons or controller buttons bound to the same actions. So from your script, you don't actually treat gamepads and keyboard input any different. They're basically the same thing.
Mm-hmm. So we've got that set up. Now we're going to add a script to our player by selecting our player and either clicking this button or right-clicking and clicking Attach Script. And this should all be fine. Make sure you save it in your scripts folder.
Yes. By default, Godot saves the script to a node in the same folder as the scene, which is problematic because you're going to have a bunch of scripts littering your scene folder. So, make sure that you pay attention to where your script is being saved.
Alright, so here's our script, and we're going to uncomment our process function because we want to use it.
suffered again.
So what we're gonna do is move our player left and right. For now, we're just gonna do those two actions. So what we wanna do is set up some variables and constants for how fast we wanna move and which direction the player is moving. So, should I open this?
You can.
I don't exactly remember how.
Oh,
Whoa
wow.
there.
Might wanna zoom out. What I did here was basically just explain the functions and then have them implement it however they want. But
Okay.
you can also just copy this. Yeah, you should probably just copy this into the script and then explain what it does.
Okay, so I'm just gonna copy this.
This script and explain what it does.
Yeah.
Yeah. There are also comments in here that I shouldn't do that. There we go. Alright, so what we're doing here is we have two variables at the top. This can actually be a const because we're not going to be changing it. So we have a constant variable or a constant value called speed, and that is an integer, and we're setting it to 100. You can make this whatever you want. And we have this variable called direction, which is a vector 2, and this is going to store the direction, whether it be left or right, that we are moving. So what we're doing is, in our process function, every single frame, we're going to set direction back to 0. So basically, if you're not moving, or if you're not pressing a key at the start of every frame, it's just going to set your direction back to that because you're not moving. So it's not going to change your direction at all. And then we have two functions here. This one's called check for input, and this one's called move player. So this is a bit complicated here. So what we're doing is, I should explain this function first.
Yeah.
So to check for input, you want to access a global object, which is just called input with a capital I.
Can
And
you
then,
go to like how you defined a direction originally?
yeah, so we just typed var direction and then colon to infer the type equals, and then just a 0 vector 2.
Okay, thank you.
Yeah. So when you want to check for input, you're going to want to access a global object that's just called input with a capital I. And then there are three, if you want to check for a specific action that you set up in the input manager, there are 3 different functions you can
We have
use.
a slide on this.
Oh, is there?
Go back, yeah.
Yeah. Or wait. Yeah. So, well, technically there's more than 3, but these are the ones that we're using. So these are similar to Unity. We have one called is action just pressed. This will return a value just on the moment that you press the key. So if you just press the key once, even if you keep holding it down, it's only gonna return true once. And then we have just is action pressed, which will constantly return either true or false every frame depending on whether you're holding down the key. And then we have get action strength.
This one is a new one for 3.1. This is to deal with the difference between getting gamepad input and keyboard input. So instead of returning a Boolean value, which get action strength, well, no, is action pressed does, you know, it's a true or false statement, what you would usually do is put that in an if statement. So, you know, if the button's pressed, do behavior. In this case, we would set the direction. If you're dealing with a gamepad, then you're actually going to be dealing with a sensitivity. So a gamepad can, you know, be from 0 to 1, where like 1 is all the way to the left, -1 all the way to the right, and, you know, a decimal in between. So what input.getActionStrength does is it actually returns a float, and that floats between -1 and 1, or I think it's just from 0 to 1 actually. And so what we're doing here is we're getting the float from that function, and so it's going to be 1 when the button's pressed, or when the gamepad axis is all the way to the right, and we're putting it in left strength. And then we're doing it for the right one, so, you know, right. And so we're setting our direction to be the difference between them. So in the case that you want to move left, you're going to be pressing A. And so your left strength is going to be 1. Your right strength is going to be 0. And the direction is going to end up being -1. And when you move your character along the x-axis in -1, it's going to move to the left. In the case that you don't press anything, both of these are going to be 0. Then your direction is going to end up being 0, and your movement won't be, player won't move at all. And, you know, in the right, it's going to be positive. Does that code make sense?
Yeah, so how you can think about it is every single frame we're setting our direction back to 0, then we're jumping into this check for input function, and depending on what the player is pressing, direction is either going to stay 0 or the x value is going to become, in this case, either -1 or 1, and that's going to determine the direction that we're going to be moving for that frame. Does that make sense? Okay, and then we also have a check for our jump button here, but we're not doing that yet, so we just put pass there.
This is basically illustrating what, if you wanted to use the is action pressed or just pressed, you would do it just like this. The function will return a Boolean value, and if you put it in an if statement, you can do behaviors depending on whether it's true or false. So later on, we're going to be putting something there that's only going to activate when the player, you know, presses space, and we can have the player jump. You can do the same thing for moving left and right. The reason I illustrated it like this is easier to implement, easier to implement both gamepad and keyboard input.
Okay, and then
Wait, can you show us how you did the setting of the so you check for input and
should we stop here and let them try to implement?
Well, we
it?
should probably show that this works.
Yeah, good idea. So let's go into game, and we have our player right there, and if we press right, we're going to move right, and if we press left, we're going to move left. If we press both, we're not going to move because it's canceling out to 0.
Yep. So the actual function that's doing the movement of the player is called translate, and if we go back to the script, it is just being run once per frame. So in our move player, we're translating, and it only takes one argument, and it is a vector2 argument, and it's basically saying, relative to where I am now, where do you want me to be next frame? Is basically what the translate function is.
Or, in other words, move the object by this much.
Yeah.
So if you, for example, if you put in vector2 3, 0, it would move the object 3 units to the right and 0 units up and down.
You can demonstrate that.
Yeah, so if we just put in, if we just said translate
Can anyone guess what this is going to do?
They move
Just
and
gonna
like
shoot him into the corner.
Let's see. So,
Whoa, that
did
was really
anyone
fast.
see that?
Right.
It's going to move to the bottom right because in Godot, down is positive y.
As it should be.
So yeah, what we changed is instead of translating based on our input, which is the direction and the speed, we're translating based on a constant value of a vector 2 of 50-50. So every frame, the player's position is going to change 50 down, 50 units down, pixels down, and 50 pixels right.
And you might have noticed our speed is 100, but when using this, we are not moving insanely fast, and that is because, let me get rid of this. That is because we are multiplying by something called delta, and we will talk about what that is in a few minutes. Any questions?
If you have the slides up, then you can just copy paste this from the link that we provided in the slides.
Are we gonna pause and let them try it, or keep going?
Well, I think they've all been doing it as we
Yeah.
talked. So is everyone ready to move on?
All right, let's talk about physics. So we're gonna set up a physical level with collisions and everything, and we're gonna move our character not with translate, but with physics. So the physics in Godot are very similar to Unity. We have 3 types of rigid bodies that we can use. There's kinematic body 2D, which is basically a physics body that doesn't really interact with the physics engine. So this is for, it says advanced character controllers. This is basically for any object that you want to move yourself. You don't want to use the built-in gravity or anything else like that. You just want to control it yourself. So if you want to do that, then you would use a kinematic body 2D. Yes.
So let's say tomorrow I'm go call crazy. I'm I'm gonna make the next Smash Bros. Would I use the rigid bodies to take my characters, or would I use kinematic bodies?
You would probably absolutely use a kinematic body. So the difference between a kinematic body 2D and a rigid body 2D. Rigid body 2D is basically your standard, regular physics object. If you have a ball, it's a rigid body 2D. It's going to bounce, and you can manipulate it without a script. Rigid bodies are completely calculated through the physics system. You don't directly say where it's going to move. You give it basically arguments. You would say, I want my velocity to be 50, and then the physics engine does the rest. Kinematic body 2Ds, you are the sole thing that moves that object, but you have access to, basically asking questions about the world around the kinematic body 2D. You can ask, is it colliding with something? You can have it calculate the next position based on, sliding with it. You can, do all of those things, but you are the thing that is moving that body. And that's what most character controllers are, is they're not, physically being, pushed around by the forces of the world. They're being, controlled by the character, and everything kind of moves in response to them. If you've ever been in a first-person shooter and you kick a box, you didn't go flying in the other direction, you kicked the box. And that's because your next position interacted with that box, and the game said, box, you're gonna fly in the other direction, and the kinematic body didn't move. If it was a rigid body, you wouldn't have any say over that interaction. It would interact with the box, and physically they would collide, and they would bounce off of each other. Yes.
How about for an enemy, something with more complex AI? Would that also be kinematic?
Yes.
Yeah. Depending on what you want, the desired effect. So if you wanted, say, a bat enemy to be kind of going towards the player loosely and then like having to like turn around and you can maybe like smack at the bat and have it go off in the other direction, that would probably be a rigid body 2D, because you're really only telling it kind of where to go and you can let the player kind of, smack it around. If it was something like, a goblin in Legend of Zelda, it would likely be a kinematic body that is very mathematically being calculated where the next move is, until it becomes a ragdoll, and then that changes things a little bit.
Does that make sense?
Any other questions about that? There is a third one, which is static body. As it sounds, it is a physics object that doesn't move. It is very good for level geometry and boundaries. So say you just have like any level. If it was a rigid body, that level would be falling. Or if it wasn't falling and you jumped, it would go down. So you don't want that. You want it to be completely static. Nothing can ever move it. But you want things to know that it's there. So it's a static body. It has colliders and everything.
And then in Unity, you can set a collider to act as a trigger. You can do the same thing in Godot with something called Area 2D, which we will get into eventually. And that's basically what we just talked about.
Yeah, well, so colliders are in Unity, if you've done physics in Unity before, the collider and the body are on the same game object. So you have a collider, you can have any number of colliders on the same game object, and that defines kind of how the body interacts with space. In Godot, the physics body is its own node, and the collider is its own node. So how do you kind of, make that relationship of a body having all of these colliders? Well, you have the collider be a child of the rigid body. So you would have, if you were to make a rigid body player, you would have the rigid body be, the root or something. And under it, you would have any number of collider game objects or nodes that would make up the collider on it. They each have their own independent position. You can scale them and have their own shapes. And they're all independent nodes. They just basically make up the collision area of their parent body. This is, an example of what a 2D character might look like. Ours is going to look kind of similar to this. This is how it would appear in the scene tree. So at the very top, we have a rigid body 2D, and that is determining the position of everything under it. And we know it has a collision shape, two collision shapes, and a sprite. And under the sprite is an animation player. And so you can think of a node with a child under it as maybe having that node as a component, as it would be in Unity.
So one problem we currently have is our character is not a physics object right now, it is a sprite. So we're going to change our character into a rigid body 2D by creating a rigid body 2D and then reparenting our sprite underneath that rigid body 2D. So
We're actually changing the type.
oh, are we?
So I did this because you're probably going to do this sometimes when you're making a character. You don't always know what your root node is going to end up being, and so you might end up dragging a sprite on and then manipulating the sprite. But maybe you want to decide that it needs to be a different sprite. Maybe it needs to be an animated sprite. You don't really want to make a whole new sprite and then set all of the things back up. You can just do something called change the type. So when you change the type, you can just choose another random node, and it's going to convert it into that node. And it's going to carry over all the properties that it can from the node that it was. So we can see that it still has the position that we set, but it no longer has any visuals.
Yes.
And it also has the script that we set.
So we're gonna add another sprite to it and drag back over our sprite. And something else we need to do is go into our script, and at the top here it says extends sprite, and this just means that it is inheriting from Sprite, but we've changed it into a rigid body 2D, so we need to change this to rigid body 2D so our sprite or our script will work correctly. Any questions?
Probably. Oh, okay, there we go. Wait. Oh no.
Hmm?
No, it's just they won't stick together. You mean the two like
Oh, I think I know what you mean.
yeah, like these two don't stick together. How do I like
Oh, do you
Oh,
want to
there is
center
a
it way on to? Do you want to center the player onto the rigid body?
yeah.
Oh, so what you're running into?
I will
yeah, you
explain
can
that.
demonstrate.
Okay, so one problem you're probably going to have is if you try to move your rigid body 2D around, you're probably going to end up selecting the sprite and moving it around, which we don't want because it's not moving our actual player, it's just moving the sprite. So what you can do is click on your player and click this button, which says make sure the object's children are not selectable. And that will make it so if you click anywhere on this object, you're not going to select the sprite or any of its other children. You're just going to select the main object, which is the rigid body 2D. And you can also click on components of it and click this lock button, and that will prevent them from being moved. So I can't move this sprite right now because it's locked, but if I unlock it, I can move it. So those are just some useful things to have.
You should also probably get in the habit of selecting nodes from the scene tree instead of selecting them in the editor window, because it's often faster to just, get to the node that you want. If you have a scene with a lot of nodes, you're probably going to end up clicking on the wrong thing or doing stuff like that. So I would get in the habit of selecting it from the scene window. We also need to add a collision shape to our character. Right now, we're going to do that later.
Yes.
We can
Okay.
do the character thing. So
Okay.
first we're going to set a property on the rigid body. If we were to use this rigid body as it was, then our character would likely fall over if we tried to move it. That is because by default, rigid bodies are expected to be just spherical objects. They can be rotated physically, and they will. There is a separate mode for the rigid body that is called character, and this will basically disallow the rigid body from moving or from rotating physically in the world.
Okay, so now we're going to add some colliders to our player. So if you look at your player in the tree, there's this yellow icon next to it which says this node has no shape, so it can't collide or interact with other objects. So we're going to rectify that by adding a collision shape 2D node to our player. So we're going to right click on here, add a collision shape 2D, and this is going to have a yellow icon because we have not given this shape a shape yet. So, which one did we use?
We use the capsule.
Okay, so if you click on shape, we have a bunch of different ones to choose from. A lot of the time you're going to be using rectangles and capsules and circles. We're going to use a capsule in this case. So
it is fun to kind of experiment with different shapes. Like specifically the raycast shape is very interesting if you have a character that just needs to know when it's on the ground. So yeah.
So we have our shape, and what we can do is drag these little orange circles, and that will scale it down. So we can make it a bit smaller.
The
Wait, how do you move it up and down?
You can use the arrow keys to move it up and down as long as it's selected.
Oh, you could have told me that earlier, huh?
So you want the very bottom of the collider to be where you want the feet to interact with the floor. So if it's any lower, it's going to look like your player is floating.
Any questions? Okay. Oh, you can also click on the capsule shape here, and you can actually set the radius and height manually if you want to, but for our purposes, it's enough to just eyeball it. We've already done that. So if we test our game now, our player is going to plummet off of the screen because by default rigid bodies do obey gravity, but we do not have any ground. So we're going to use a static body 2D to make our ground. So we're going to add that as a child of our scene.
I think there would be issue. Oh, wait.
Alright, so we can rename this and just call it ground. And let's add a sprite just so we have a frame of reference for how big it is. And I think if we go in, do we need to pull it from this?
I don't remember what I did.
Should we just use this?
Yeah, you should just...
Okay, so if you're ever testing, you can, having this Godot icon is great because you can just put it on anything you want and use it for testing purposes, which is what we're gonna do. There's our lovely floor, and we're gonna add a collision shape to this, which will be a rectangle shape. You can hold shift with the arrow keys to move it faster. And just drag this till it fits our ground. Now if we run the game, we will land on the ground. Very handsome ground.
Very handsome.
Just has to be functional. That's all that matters. All right, any questions before we move on? Okay. So, someone say something?
Yeah. So, how exactly do we set the rectangle collision shape?
So, which part? Do you mean assigning it to the
Yeah.
collision? So, if you click on the collision shape and come over to the side, there should
does
be...
it automatically like set it to that thing? Or?
No. So,
I think you have your sprite moved different to where your actual thing is. Set the transform down to 0. Okay. Go back. Here.
Other
No,
direction.
it's not there. Okay, there it is. So your rectangle collider is here. So you would just do that.
Okay.
And then you would probably do what we did here is with this, change this so that you can actually move from this thing. Same
Okay.
thing.
Thank you.
All right, so now we are going to add some movement to our character again, because we cannot use the translate function to move a rigid body, which is good because you never want to do that. So we're going to change our functions so that they work with the rigid body 2D class, and we have a link here that is out of date.
Yes.
That should be 3.1, and this will take us to a page that tells you all about the different functions and member variables and everything of the rigid body 2D class.
So if you have a script that extends rigid body 2D, then you can access any of those member variables and modify them.
Yeah, so like, what was
You can
one
open
of
it in the editor.
That's also true. So also, if you forgot from last time, you can control click on this and it will take you right to the documentation for it. So for example, this has a variable called weight. So if I just type in weight, it will very slightly change color. It's very hard to see, but that indicates that that is a member variable in this object, and you can change that. But we're going to leave that alone for now. So the closest thing to what we're doing with translate is setting our linear velocity inside our move player function. So instead of doing this, we're just going to say linear velocity. You can also do, this is a bit more good practice. You can also do set linear velocity, and if you go into here and click on any of these, where is it? Click on any of these variables, it'll actually tell you what the setter and getter functions are, and it's generally good practice to use these instead of just setting it directly, because in other programming languages you wouldn't be able to set it directly, but GDScript doesn't have any access modifiers or private variables, so you can just set it directly if you want, and sometimes it's more convenient.
It
But
will call the setter and getter automatically. If
Yes.
you've ever used Python, you can do the same thing by having a setter and getter attribute. So technically it doesn't matter. I don't think I ever use setters and getters, but if you want to have your code look a certain way, you can use them or not.
I'm just going to say linear velocity equals direction times speed times delta, just like we have up here. And this should... Oh, I did not do this right.
You multiply by delta.
Do I not need to multiply by delta?
No, because we're setting the velocity.
Oh, right, okay.
So if we run, then we can see we're no longer falling. What the heck is happening? So,
We're falling a little bit.
yes,
Yeah, we're
you're
falling a little bit.
So the thing that is happening here is we are directly setting linear velocity to our direction variable, which, as you might remember, we never change the y. So y is always going to be 0 in our direction. But if we set our linear velocity, its y component, to 0, then that means we're no longer affected by gravity. So what we need to do is we need to ignore our y component in our linear velocity. We can do that by setting the x component, and you can do this with any vector 2. You're setting it to a vector 2, direction.x as well. So for any vector 2 or vector 3, you can access their components with .x, y, or z. So right now we've changed it to linear velocity.x is the x component of the direction times our speed. And we're no longer multiplying by delta, but we never explained delta, so.
So now we fall normally, and we can still move left and right. And we should be able to fall off of this. Mhm.
Oh, if you hold to the ledge,
falling
you
very
stop falling
quickly.
a bit.
What?
We're not falling very quickly.
Yeah.
Oh, I think it's because we're doing it in process.
Yeah, we'll get to that later. Any questions? Yeah.
This is just like an interesting bug I found already. So if we're falling, and then if I like fall off the platforms, I mean this is not really, and if I hold to the platforms, I don't fall.
Yep.
Yeah, that's just a quirk with how the physics work, basically.
You have very similar things happening in Unity as well if you try to do the same thing.
For sure.
Creating
Just
a,
the aspect of how you implemented that movement,
yeah.
not necessarily the engine.
All right, so now that we have our physics implemented, we're going to add jumping to our character. And we can do that with the apply impulse function in the rigid body 2D. So we're going to make a new variable for that called jump force.
Terrible game.
And we can make that const. And that was it was 500. So now we have our jump force, and then we can make a new function called jump. And in here we can say apply impulse. Is this gonna be 0, 0? Or
I have the paste bin. I believe it's 0, 1, and then this force,
okay.
-1 actually. And then the jump force. Oh, it said vector. Oh.
Let's see what the script says.
Apply impulse. Oh.
Okay.
Okay, I understand.
That's sick.
So this apply impulse command, or function I should say, this is basically setting the, well, it's applying an impulse. It's basically an instantaneous force from some position. So what we're doing here is the position that we're applying the force from is the actual position of the rigid body, and that would be the global position. There is a local position as well, and the difference is the global position is relative to the world, local position is relative to the parent. So the actual force we're applying is a vector 2 in 0 in the x direction and negative jump force in the y direction. And it's, you know, negative because we're going up, and the jump force is the force to be applied. Yep.
So what does it mean when it says method apply impulse is not declared in the current class?
It might have not changed the.
No, he changed the extends. Is it named correctly? Yeah. That's weird.
So if we play this,
You didn't
oh,
assign the
we
jump.
didn't actually do anything. Never mind. Let me just do that. Jump in our little jump function. And then if we play it, we can jump. Maybe, hopefully, jump.
Hmm.
I think I ran into this last time.
There you go.
I do that all the time, don't worry.
This was actually working when I tested it like 2 seconds ago. Of course. Did you name it right? Input map? Oh yeah. Should be working.
That's weird. Try positive jump force, just in case.
Oh, maybe. Also. Hey.
That's probably good too.
So this is something that I do all the time. This is tabs. Is if you want to know that your code is actually doing something, just print wherever it's running.
You see it? It's ran.
Oh, it's that.
It is actually running.
Aw.
Interesting. So screw this. We're just going to be setting the linear velocity
Don't actually do this.
Dot
when you
Y.
make a game, but
to negative jump force.
Or rather, if you do this, have a good reason for it,
Yeah.
not just because it's easy.
so now it. There we go.
So now when you jump, you actually jump. So that was a lot, but now that I know that my jump force is supposed to be a lot lower, I have to quit the game. I have to go back here, change it down to say 100, and again, see if that's enough. And maybe it was enough, maybe it wasn't. But that kind of cycle gets really repetitive when you start trying to like fine-tune variables. So in order to actually accommodate for that, we can actually set these variables from the editor. And the way to do that is with a thing called export bar.
If you use Unity, this is basically just public or serialized field.
Yeah. So now that I say export these variables, then in the inspector for my player, we can see 2 new script variables popped up. So now I can edit these from here, and they're just, you know, integers. So say 50 there, or I can maybe just set it to 1. So now I can jump, and it's not jumping very hard. So now I can actually edit that value while it's running, and go here and say I want jump force to be 100 again, and then go back into the running game, and it's updated. And so that's a very useful tool for actually kind of debugging and fine-tuning variables while you're in game. And you can also change, you know, positions and all sorts of stuff like that. Though it is very important to keep in mind that that change will not carry over when I exit the game. So if you have actually found your whatever value that you want to go back and set it in the actual editor, because the changes will be lost, very similar to Unity.
You can also have it so that the changes won't be lost, because you can have it sync the scene and the scripts to the active player.
Really?
Yes.
I have never done this.
If you go to the debug.
Sync changes, right? Like this?
Yeah.
So would you turn these off, or?
Well, no, having those enabled is what allows you to make changes to code or something while it's still running, and then it will automatically sync the changes.
Okay, interesting. All right. Try that.
Problem is, it doesn't ever come back down.
Yes. So this isn't a very good game we've made, and we leave it to you to actually use these tools to make something that's functional.
How do I use apply impulse?
A what?
Apply impulse.
We'll get back to you on that. That's probably not the right tool
They
for this job.
probably changed it in
Yeah.
3.1 somehow.
So yeah, we just did all of that. This is the final script. I swear it works. I tested it. Whatever we did, it was weird. So, what else do we have here?
There's a lot left.
Okay, how much time do we have left?
We are 20 minutes over time.
Okay, so we should probably do this next time then, because I think I did this last time as well.
Yes.
Switch prefabs. Does anyone have any questions about that?
Yeah. So, what's like the advantage of like Godot over like Unity? Like, which one would you choose for?
So we have actually we had slides about this last time, but you can achieve the same things with both. Basically across the board, they trade blows in there's very minor advantages here, very minor advantages there. There's differences in how the Godot actually, does things. There's the node system. Instead of being composed of components, you're composed of nodes. For some games, that makes more sense. For other games, that makes less sense. I personally like how Godot does it better. There's a thing that Godot used to do better than Unity, and that was prefabs, in that scenes. Let me just demo this really quick. Scenes are the same things as prefabs. So if I can save this as a player, this player is now its own scene, and I can set it back to 0, 0. So we see player is the root of the scene. It's an actual .tscn file, and here it is just basically a link to that file. And we can put as many of these here as we want, and probably not child them to the player, but basically you can nest scenes in this way. And so all of these have basically become prefabs, and every change that you make to player is going to make that same change to all of these. And you can have multiple of these scenes in here, so I can actually make like this sprite a prefab and put more sprites in here, and it kind of nests in that way. Unity now has nested prefabs. They didn't when I was using it, but yeah. The difference in why I like it so much over Unity is, one, it supports Linux natively and it doesn't suck, and two, it's free and open source. So there's no license agreement that you sign to use Godot. For Unity, if you make over $100,000 a year, then you have to show your revenue with Unity. Unity has a say in what you do with your final product. So if you say want to do something and Unity views that as something they don't want you to do, then they can just revoke your license. You're not allowed to do anything anymore. You're screwed. That actually kind of happened recently, there was a software or a tool for Unity that was used in making MMOs in Unity easier. It was like a networking layer, and they got in a disagreement with Unity, and so it looked like for a while Unity could just say any games made with this can't be published anymore, you're all screwed. And that was a really scary situation, and they were kind of in talks with Unreal about getting the software over to Unreal. And so if that kind of happens, you're developing a game using that software, you're screwed. Like, what are you gonna do? Just remake your whole game? So with stuff like Godot, there's no license agreement. It's all open source. You can make contributions to it if you want. Say you run into a bug and you need it to be fixed, you can go fix it if you know how. You can make feature contributions and all of that stuff. So does that answer your question? Okay.
So you're saying that anyone can make any games of any type whatsoever, and they're not going to be stopped?
Mm-hmm.
Yes, because
Even the weird raunchy games I find are like weird ads.
yes, there is literally nothing anyone can do to stop you from publishing software made with Godot.
Unless you put it on like Steam and they don't
Yeah.
like it.
Right. At least
Um,
Godot's licensing won't restrict you from doing things with it.
Yeah. Godot isn't a company. It is a collection of people that are working on it, and none of those people have the power to say what you can and cannot do with it. You can even fork Godot, make your own version of Godot, and sell it. Like, literally, that's allowed. So yeah, that's why I like Godot. I think open source software is important, and so yeah.
So,
We're also like super late, so I'm probably gonna stop the stream.
But what
but
about
we
like,
can
you know,
continue.
the strategy, the